Ever wondered what factors affect chemical processes and how API manufacturing works? Well, you're in for a treat. Chemical processes, a cornerstone of numerous industries, are fascinatingly complex. They involve the transformation of raw materials into desired products through chemical reactions, separation, and purification. It's intriguing, isn't it? Now imagine the significance of these processes in the pharmaceutical industry. Picture the creation of life-saving drugs, the magic of turning raw substances into medications that cure diseases, alleviate pain, and improve quality of life. This is where understanding chemical processes becomes vital. Active pharmaceutical ingredient, API manufacturing, for instance, heavily relies on these processes. APIs are the very heart of any medication, the substances that produce the intended effects. Understanding how they are produced, the equipment used, and the layout of these processes is nothing short of crucial. Now that we've set the stage, let's delve deeper into the factors affecting these chemical processes. So what exactly influences these chemical processes? Well, let's dive right in. There are numerous factors that can affect chemical processes, but we'll focus on 5 key elements: temperature, pressure, concentration, catalysts, and inhibitors. First up, temperature. We all know that heat can speed things up, and the same goes for chemical reactions. Increasing the temperature typically speeds up a reaction because higher temperatures increase the energy of the molecules, causing them to collide more frequently and with more force. Picture it like a bunch of hyperactive kids in a room full of balloons. The more they run around, or the higher the temperature, the more balloon popping or reactions you're going to get. Next, we have pressure. This mainly influences reactions involving gases. Higher pressure pushes molecules closer together. Imagine squishing a sponge. The water molecules inside are forced closer together, and similar to our balloon popping kids, more collisions lead to more reactions. The third factor is concentration. Simply put, the more stuff you have in a given space, the more likely it is that stuff will bump into each other and react. More molecules in a space means more potential reactions. It's like increasing the number of kids in our balloon room. More kids, more popping. Catalysts, our fourth factor, are like chemical matchmakers. They help reactions along without being used up in the process. A catalyst might help a shy balloon popper by showing them the best popping technique, increasing the overall rate of popping. Finally, we have inhibitors. These are the party poopers of chemical reactions. They slow things down by getting in the way of the reacting molecules. An inhibitor might be a kid who hates the sound of popping balloons and does everything they can to prevent others from popping them. As we can see, even minor changes in these factors can significantly alter the outcome of a chemical process. From the speed of the reaction to the products that are ultimately formed, these factors hold the reins of chemical processes, and mastering them, well, that's the key to controlling the wild and wonderful world of chemistry. Now let's turn our attention to a specific application of these processes: API manufacturing. API, or active pharmaceutical ingredients, are the crucial components that give medicines their therapeutic effect. Without APIs, your aspirin wouldn't soothe your headache, your antibiotics wouldn't fight infections, and your insulin wouldn't regulate your blood sugar. APIs are the heroes of the pharmaceutical world, and their manufacturing process is a marvel of modern chemistry. The production of these mighty molecules demands precise control over chemical reactions, meticulous monitoring of conditions, and an intricate understanding of chemical processes. Just imagine every time you pop a pill, you're benefiting from an orchestra of chemical reactions, carefully conducted to create the API that helps you heal. That's why the manufacturing of APIs is so important, and why it's a topic worth exploring in depth. You might be wondering what goes into the manufacturing of these APIs. Let's find out. API manufacturing is a complex process that involves several steps. It's like an intricate dance where every step must be perfectly timed and executed to ensure a successful performance, or in this case, a high-quality API. The first step in this dance is the procurement of raw materials. These are the building blocks of our API, and choosing the right ones is crucial. Various chemical processes are used to assess the quality and purity of these materials. It's a bit like a chef selecting the best ingredients for a gourmet meal. Next up is synthesis. This is where the real magic happens. It's where our raw materials are transformed into the active pharmaceutical ingredient. This stage involves a series of chemical reactions, each carefully controlled to ensure the right product is formed. Think of it as following a recipe to bake a cake, but with chemicals instead of flour and sugar. Once we have our API, the next step is purification. This is where unwanted byproducts from the synthesis are removed. Various chemical processes come into play here, including filtration, crystallization, and distillation. It's akin to sieving flour to remove any lumps, ensuring a smooth and flawless cake. Finally, we have packaging. This might seem like an afterthought, but it's actually a crucial step in maintaining the quality and stability of the API. Here, chemical processes are used to determine the best packaging materials and conditions. It's like choosing the right cake box and storing conditions to keep the cake fresh and delicious. Clearly, API manufacturing is a delicate balancing act of various chemical processes. Each step is connected to the other, with chemical processes playing a vital role in each stage. It's a dance that requires precision, patience, and a deep understanding of chemistry. But when done right, the result is a safe and effective API, ready to be used in life-saving medications. But how is all this done? What tools do we need? Well, let's dive into the fascinating world of equipment used in API manufacturing. First off, we have reactors. The heart of the operation, reactors are where the magic happens. These large vessels are designed to handle a variety of chemical reactions. They're where raw materials undergo transformations to become the active pharmaceutical ingredients we need. Equipped with temperature and pressure controls, reactors ensure each reaction proceeds under optimal conditions. Next up, centrifuges. Once the reaction is complete, we need to separate the API from the rest of the mixture. That's where centrifuges come in. Spinning at high speeds, they use the principles of centrifugal force to separate the solid API from the liquid solution. Then we have dryers. After the centrifuge has done its job, we're left with a wet API. Dryers eliminate the moisture, leaving us with a dry, pure, active ingredient. Dryers are also crucial in maintaining the stability of the API, as certain active ingredients can degrade in the presence of water. After drying, the API is often coarse and needs to be refined further. That's where mills come in. Mills grind the API into a fine powder, ensuring it's of the right size and consistency for the next stages of drug manufacturing. Finally, we have packaging machines. After all the manufacturing, refining, and testing, the API needs to be packed in a way that it remains pure and stable until it reaches the drug formulation site. Packaging machines accomplish this task with precision and efficiency, ensuring the API is ready for transport. So there you have it. From reactors to packaging machines, each piece of equipment plays a vital role in API manufacturing. They work in synchrony, each one contributing to the creation of the life-saving drugs we depend on. These tools are the unsung heroes of API manufacturing, working behind the scenes to make life-saving drugs. Now that we know what equipment is used, let's look at how they're arranged. When we talk about the layout of process equipment in API manufacturing, we're referring to the strategic placement of machines and devices in three primary areas: input, processing, and output. It's like a well-choreographed dance where every dancer, or in this case, equipment, knows its place and function. In the input area, raw materials are stored and prepared for processing. This area often includes storage tanks, silos, and conveyors to move materials to the processing area. The layout here must ensure easy and safe access to materials while minimizing the risk of contamination. Moving on to the processing area, this is where the magic happens. The reaction systems and processing equipment, such as reactors, distillation columns, and centrifuges, are arranged to facilitate efficient chemical processes. The layout here should focus on seamless flow of materials, reducing downtime and optimizing productivity. Lastly, the output area is where the finished APIs are collected, packaged, and stored for distribution. Equipment like filters, dryers, and packaging machines are set up here. The layout must ensure easy retrieval and packaging of the final product. An efficient layout of process equipment doesn't just happen by chance. It needs meticulous planning and design, taking into account safety regulations, workflow efficiency, and ease of maintenance. Remember, a well-planned layout is not just about aesthetics, it's about functionality. A well-planned layout is crucial for a smooth and efficient manufacturing process. We've covered a lot of ground today, haven't we? We've explored the fascinating world of chemical processes, delving into the factors that influence them. We've journeyed through the intricate API manufacturing process, and examined the essential equipment used therein. We've even peeked into the strategic layout of process equipment. All these elements working in harmony shape the world of pharmaceutical manufacturing. Subscribe for more because you won't find me later. Until next time, keep wondering and keep learning.